early founding fathers of Seattle started dealing with the fact that their population was growing, there was inevitably a demand for more power. They came out here looking for the energy that could make that stuff. The problem, though, was designing a system that could turn that energy into electricity.
The Puyallup River starts in the Cascades, 16,000 feet above sea level, and flows 45 miles downhill and northwest towards the city. It's just one of the dozens of rivers and dams that provide Seattle with 90% of its electricity. I'm driving up to the foothills of Mount Rainier to get an insider's look at one of them, the Electron Project, a 100-year-old hydroelectric engineering marvel that's still providing power for Seattle today.
Gene.
Hey, how you doing?
Gene Galloway has been working on the Electron Project for 38 years.
When did this whole operation start?
It started about 1900.
Seattle, Tacoma, all these areas are growing in population.
Yes.
And they're demanding what all those people back east take for granted.
That's correct.
They want the same thing. They want electricity.
They want electricity.
So how is this water delivered to the point of making this energy?
It flows in a 10.5-mile flume. It's an 8x8 wooden box.
Gene explained that instead of trapping the river behind a massive dam to create power, the Electron channels it into a 10-mile-long flume. After the water is diverted from the river into the flume line and makes its journey down the mountain, it collects in a reservoir, then rushes down through pipes called penstocks into water wheel-driven turbines in a powerhouse. The flume stretches through rugged and treacherous terrain, and the only way for me to see the entire length is by a special rail line open only to Puget Energy workers.
Here comes the train. Cool.
The original workers laid these tracks on top of the flume as a way to maintain and inspect the line over 100 years ago.
Look at this. This board doesn't look so secure. But we are going on this little rail car on top of this flume full of a torrent of water. Basically, this whole track runs the distance of this flume 10 miles down the mountain. That's where we're going. Okay, so we're leaving the station here, huh?
We certainly are. All aboard?
We'll be chugging along at the blistering rate of 7 miles an hour. Any faster, and we might come off the tracks.
We're traveling here pretty slow at a pretty flat grade. That's intentional, yeah?
The plan, the design called for an 8-foot drop per mile. You don't want the water to get going too fast, or it'd bore a hole in the ground, and you may not be able to stop it. That is also one of the reasons that the curves are in the flume.
There are 275 curves along the track, earning it the nickname, the crookedest railroad in the world.
This is the original design in terms of the flow.
Yes.
Man, they knew what they were doing back then.
They were brilliant engineers.
One of those engineers was Sam Shuffleton. Largely self-taught with only a grade school education, Shuffleton took on the Herculean task of supervising the Electron Project in 1902. Workers had to fell giant old-growth trees, build on the side of an 800-foot ravine, and deal with mountain lions, rain, and snow. 18 months later, the flume, the track, the power station, all of it was up and running.
They must have had an enormous workforce doing this.
The reports are that there were between 1,500 and 2,500 people working on this project.
Wow. Somebody switching on a light switch in Seattle has no idea that out in the middle of nowhere, there's a flume that looks like the 1910s.
All they know is that the light just came on.
Wow, look at it just dropping off here.
Here's a steep shot to the river. Woo. Right here.
Yeah. This little tiny train car is like vibrating all over and rocking back and forth, and it feels like it's just gonna go right over on one of these curves. Bam, right down there. Like an amusement ride from hell. How far down is this river?
850 feet.
This is scary. This is scary.
It's one of those places where you have to really pay attention to what you're doing.
I'm seeing a cross here. George, somebody died here.
Yes, one of the constructors in 1984 fell off here and died.
You're kidding.
No.
2 men have died over the years to keep this project up and running.
What do you want to do? Just want to walk down here. I got to get a sense of what that feels like. Nothing will happen, I promise you. Nothing bad will happen.
Be careful.
Yeah. So high over all of this incredible terrain. Just to get a feeling of what these guys did to build this. Such an intense feeling. You got the water underneath of you and about 800 feet of space of ravine straight down. You don't want to fall down. Very slippery board. That's scary out there. So this is the power plant itself.
This is the powerhouse.
All right.
The water's twisting 10-mile journey ends here.
I see the pipes coming right over the hill.
Yep, those are the penstocks.
Penstocks.
Yes.
The penstocks channel the water into a tiny but incredibly strong stream, going 500 miles an hour when it hits the water wheel turbines, and then is discharged out of the plant.
Whew! That is a vigorous flow.
Yes. This is a result of the turbine discharge.
This is the best place to see the power of water and how it generates 14,000 kilowatts of electricity for Seattle.
So can we get inside here?
Yeah, we certainly can.
Whew! Look at those things.
Usually, only Puget Energy employees get to see the heart of the Electron Project.
Each one of the units has 2 water wheels driving the generator.
So under our feet, that water is turning those water wheels.
Yep.
That shaft is driving this, and you're making electricity.
Yes.
AC current heading out.
Heading down.
Nice. 1903. This is still the same machine.
Yes.
The whole thing just works 100 years later. It's like everything here. They just left it as it is because it worked. I mean, if it ain't broke, don't fix it.
The plant produces enough juice to power 17,000 households in the Seattle area. And it's all thanks to the snows of Mount Rainier and 100-year-old engineering know-how.